Hello everyone, welcome back to my Wave. Let me ask you something today. When you're designing an RF system, maybe a radar front end or a high frequency test setup, how do you make sure that your expensive amplifier doesn't get damaged by the reflected power? Or even more important, how do you decide whether to use a Faraday isolator, a junction isolator, or a circulator? Because honestly, they all look similar on paper, but they behave very differently in real systems. Let's break it down like we would in a design review. Think of an isolator as a one-way RF wall. You send power forward, it goes through. If anything comes back as a reflection, it does not reach your source anymore. Instead, it gets absorbed or safely dissipated. So in simple terms, forward signal is allowed and reverse signal is blocked. The isolator also improves the effective VSWR seen by the amplifier, even though the actual mismatch still exists downstream. Now here's where people usually get confused. You'll see two common types: Faraday isolator and Y-junction isolator. The Faraday isolator uses Faraday rotation principle inside a magnetized ferrite. So what does that mean practically? Forward wave passes cleanly, reverse wave gets rotated incorrectly and is absorbed. Now the trade-off. It is slightly more expensive than the junction isolator. It is slightly bigger than the junction isolator, and insertion loss is higher for the Faraday isolator. We offer 116 series, which is compact style of Faraday isolator. Please visit our website for more information. Now, the Y-junction isolator is a different philosophy. It is basically a circulator with one port internally terminated. So instead of fancy physics rotation, it uses routing plus absorption. Now, here's the key engineering behavior. The one we make at MyWave is narrowband, but it can handle higher RF power, and it is more cost-effective than the Faraday isolators. So if someone asks, when should I choose a Y-junction isolator? You would say, when bandwidth is limited, low insertion loss is required, when power handling is critical, when cost matters in system design, and size is a constraint. You would choose Y-junction isolator. We offer this up to 110 GHz. Now let's move to circulators. This is where the system design becomes interesting. A circulator is a 3-port device where RF energy moves in a circular direction. Port 1 to port 2, port 2 to port 3, and port 3 to port 1. So instead of blocking energy, it routes it. Now in real RF system, this is extremely useful. The Y-junction circulator is basically a waveguide structure shaped like a Y, using ferrite materials and magnetic bias. What it does is guides RF energy from one port to the next, maintains isolation between the ports, and handles high power levels efficiently. So in practical engineering terms, you will see it in radar transmit-receive switching, high power microwave chains, RF test setups, and antenna feed networks. A very common use case is simultaneously transmit and receive operation. For example, in radar systems, one port connects to the transmitter, second to the antenna, and third to the receiver. Now compare that with using a switch instead of a circulator. If you use a switch, you can either transmit or receive, not both at the same time, so it becomes a time-sharing system. That's fine for some systems, but not for the real-time radar or a continuous monitoring. However, in a circulator, when you transmit, energy goes out to the antenna. When echoes come back, they're routed cleanly to the receiver. That means you can transmit and receive at the same time using a circulator. Another very common example is a radar target simulator setup. In those systems, a circulator is used to inject a signal into a channel, simulate a reflected target echo, and route the signal back to the receiver path. So it behaves like a controlled echo router inside the system. You will also see circulators in RF test benches for separating forward and reflected power, antenna measurement setups, duplex communication systems, and transceiver modules in satellite payloads. So when you look at real systems, isolators are mainly about protection, while circulators are about signal routing and enabling simultaneous transmit and receive operation. Hence, instead of thinking of these as just components, think of them as tools. Isolators protect your system, circulators organize your signal flow. And choosing the right one is really what makes an RF design stable, efficient, and reliable. We offer waveguide versions of these isolators and circulators. Alright, that's it for today. Thanks for watching. See you next time.